Something huge went into Uranus and left it absolutely ruined. Long ago, Uranus took an absolute pounding, according to researchers who managed to reveal this without giggling. My, isn't Uranus full of surprises? In the distant past, Uranus was hit by a huge object roughly twice the size of Earth, which left the planet tilted sideways, and could account for how cold it is. Astronomers at Durham University, UK ran the first high-resolution computer simulations of different massive collisions with the ice giant to try to work out how the planet evolved. The research confirms a previous study which said that Uranus' tilted position was caused by a collision with a massive object, most likely a young protoplanet made of rock and ice, during the formation of the Solar System about 4 billion years ago. The simulations also suggested that debris from the impactor could form a thin shell near the edge of the planet's ice layer and trap the heat emanating from Uranus' core. First pictures of girl, 6, found dead near disused hotel hours after going missing. All 12 boys and football coach trapped in Thailand cave found alive. Sunbathing woman refuses to move for couple's wedding photos. The trapping of this internal heat could in part help explain Uranus' extremely cold temperature of the planet's outer atmosphere, -216 degrees Celsius, the researchers said. The findings are published in the Astrophysical Journal. Lead author Jacob Kedgeris, PhD researcher in Durham University's Institute for Computational Cosmology, said, Uranus spins on its side, with its axis pointing almost at right angles to those of all the other planets in the Solar System. This was almost certainly caused by a giant impact, but we know very little about how this actually happened and how else such a violent event affected the planet. We ran more than 50 different impact scenarios using a high-powered supercomputer to see if we could recreate the conditions that shaped the planet's evolution. Our findings confirm that the most likely outcome was that the young Uranus was involved in a cataclysmic collision with an object twice the mass of Earth, if not larger, knocking it onto its side and setting in process the events that helped create the planet we see today. Uranus is similar to the most common type of exoplanets, planets found outside of our solar system, and the researchers hope their findings will help explain how these planets evolved and understand more about their chemical composition. Co-author Dr. Luis Teodoro, of the BEAR, NASA Ames Research Center, said, all the evidence points to giant impacts being frequent during planet formation, and with this kind of research we are now gaining more insight into their effect on potentially habitable exoplanets. The research was funded by the Science and Technology Facilities Council, the Royal Society, NASA and Los Alamos National Laboratory. NASA's Voyager 2 spacecraft flew closely past distant Uranus, the seventh planet from the Sun, in January 1986. At its closest, the spacecraft came within 81,500 kilometers, 50,600 miles, of Uranus's cloud tops on January 24, 1986. Voyager 2 radioed thousands of images and voluminous amounts of other scientific data on the planet, its moons, rings, atmosphere, interior and the magnetic environment surrounding Uranus. Since launch on August 20, 1977, Voyager 2's itinerary has taken the spacecraft to Jupiter in July 1979, Saturn in August 1981, and then Uranus. Voyager 2's next encounter was with Neptune in August 1989. Both Voyager 2 and its twin, Voyager 1, will eventually leave our solar system and enter interstellar space. Sorry, you've probably been saying the word Uranus wrong your whole life. Voyager 2's images of the 5 largest moons around Uranus revealed complex surfaces indicative of varying geologic pasts. The cameras also detected 10 previously unseen moons. Several instruments studied the ring system, uncovering the fine detail of the previously known rings and 2 newly detected rings. Voyager data showed that the planet's rate of rotation is 17 hours, 14 minutes. The spacecraft also found a Uranian magnetic field that is both large and unusual. In addition, the temperature of the equatorial region, which receives less sunlight over a Uranian year, is nevertheless about the same as that at the poles.